Okay, so there's two ways you can do this. I'm going to do number one the easy way. We're just going to AB. It's just going to be rise over run. So all you have to do, the easy way to do this, is just to say, well, I'm going up 20 and write 5. So that's 5, that's 20. So it's going to be 20 divided by 5, the slope is 4. I'll do the next one using the y2 minus y1. Okay? And then we'll go from there. Does that make sense how I got 4?
Yeah.
Okay.
Visit it.
So for BC, I'm going to use y2 minus y1 over x2 minus x1. y2, in this case, is going to be 50. Minus 20 all over 10 minus 5. Now how do I get 50 and 10? I said my second point here, point C, was 50 comma 10, or 10 comma 50. So my y2 is going to be 50, my y1 is going to be 5. 50 minus 20 is 30, divided by 5, which happens equals 6.
What? Oh, please.
C to D. I'm going to do y2 minus y1 as well. Did I go backwards?
Yeah, I got that like.
You could have done negative 30 over negative 5, that's fine. Which is just positive 6 still.
No, but like I got 5 over 30.
Just remember y comes first. Y, you know what I mean? It's 1 over x. That's what I can remember.
Yeah, but like when you're taking points, don't you choose like the bottom?
Right, but your x here is 10, right? Like this point, this coordinate point is 10 comma 50. So your x has to be, your x value is 10, your y value is 50. It's just confusing because your point.
I don't even think I had a 10 in there. I don't know what I did.
Okay. But the idea is, right, you know what I mean? The x has to come first, but it's in the denominator.
Yeah.
For your slope, though. Okay. Y2 minus y1, that's going to be 50 minus 50, all over 15 minus 10, and that's 0 over 5, and that's 0. Why does it make sense that this is 0 without even doing any calculations? There's no rise to horizontal line. Okay. Finally, DE, y2 minus y1, all over x2 minus x1, which should be 10 minus 50 over 20 minus 15.
Ooh, that's negative
40 over 5.
Yeah.
Negative 8. Why does it make sense somewhere other than Mason? Okay. Why does it make sense that BE is a negative
Because we're
slope?
going down.
Because we are dropping, right?
Yes.
And it's okay to have a negative slope, that's fine. Okay, let's go into what this actually means in English. Okay,
You have to write out what it means to me.
yeah, I'm just going to do a little paragraph here at the end here, okay? So what this actually means. So for line AB, you had, what would the units maybe be for distance? We didn't actually say minutes, didn't actually give units to it, but what might be a typical unit for distance?
Meters.
Meters could work, okay?
Meters, centimeters, kilometers.
Something like that.
millimeters.
Let's just pretend it's meters. Let's just pretend it's meters, okay? What's a typical, or miles? You could use any distance. What's a good typical unit for time?
Hours,
Maybe?
minutes, seconds.
Seconds is good.
Years.
Therefore, my slope,
You have to write that down.
yeah, is 4 meters per second. Has anyone here gone driving with their parents?
Yeah, all the time.
Okay, so Ethan, how fast does your father drive down the road? Very good answer, okay? But I'm going to say he says 80. What unit does he drive down the road at? 80 what?
Kilometers per hour.
Kilometers per hour.
Okay.
So meters per second, the unit for this. So this is the speed. The slope of a distance time graph is its speed. The steeper the line, the faster you are going. So that's sort of my summary. The slope of a distance time graph is going to be your speed. The steeper the line, the faster you're going. So again, if I were to do this scenario, I'm going to use myself as an example, walking so slowly up the stairs. Okay? So I'm starting to go a little bit, I'm doing my regular walk. That would be from point A to point B. From B to C, I'm going a little bit faster, not much faster, but I'm going up to 6. So I might do a little bit of a jog to get there. Then I take a break from C to D and I don't move. In D to C, I'm going to run home or turn around and go really fast in 1 minus 8. So I'm going very fast in the backwards direction.
So it goes like really slow and then it starts picking up.
So that's what happens. I'm going relatively slow because it's not that steep. Right? Then it gets steeper, so I'm going quicker. Then I take a break and then it's really steep going backwards. That makes sense, right? So again, you're starting off going sort of moderate, pick up the pace, take a break, and then turn around. And you guys should be good at this, or getting good at this after all this stuff here we've done, right? Because this is sort of the application. All of these graphs, pretty much, are distance time graphs. Okay, right? And as you'll see, the speed of things. No, okay. No, okay. Look, you're thinking different. If this was I like where. 1 second, please. 1 second, please. Okay. I like where you're thinking you're going to love physics in a few years. Okay. That would work if you're dealing with speed. This is just their motion. So this is just showing their motion. So if I do this, my motion is, if my position doesn't change, I have no speed, right? And I'm running backwards. So that's going to be how far you are from the clock. Please make sure you take physics when you get the option grid ladder.
Ew, don't take physics.
Don't listen to her. Take physics.
No, it's all just like equations.
Oh, math and equations. Awesome.
I'm just getting math.
Okay, here we go. Letter example 2. This is our last example. Here we go. It's our last example.
Wait, do you want me to tell her? Do you even know how hard to like calculate height?
Example 2. Here we go.
No, I have a proof there.
Same phrase. First of all, this never happened again. You guys can sit together after.
Okay, that's fine. Well, I just wanted to be able to see something.
Mr. Sadler has 50 liters of gas in his truck.
Mr. Sadler, that's
In my imaginary truck.
what do you whip in now? Like, what do you drive now?
There we go. After traveling 120 kilometers, he has 30 liters of gas left.
What's Jenny? One goose bag over there. This statement, not a question. I didn't do it.
Hey, sit down, please. Sit down. Can you get through this, please? Okay. Hey, sketch a graph for this. Now, when I say sketch a graph, that means just a rough thing is all I need. B, calculate the slope. And C, explain what the slope means in the scenario. Okay, I'm going to pause the video. When I pause the video, when we come back, you guys will have A and B done. Okay, I will take you through number C. So I want you to do a rough sketch. A rough sketch. Cover your paper because you do an excellent example of a rough sketch. Pop it open. Hey, you guys probably can't see if you're sitting at the back, but this is a rough sketch right here. Okay, a little diagram just drawn quickly. That's a rough sketch. That's all I need to see for this. Okay. If I say graph means graph. Sketch means you can just put in your notes quickly. Okay.
But it
If
has
you
to be
wanted-
a graph.
Yeah. So sketch a quick graph of this. Letter B, calculate the slope. You should be able to calculate the slope as well. No problem. Letter C, I'll do the explaining for you. Okay? Let's pause this and go.
I don't know how well I'm going to be able to do this.
You can do it.